Hey, what's up, guys? Chung here again. And so this time, let's take a look at this LeetCode problem here, number 1312, minimum insertion steps to make a string palindrome. Another classic, not classic, but another a string palindrome problem. You know, I think it's very easy, very very simple description. Not easy, sorry, simple description. You're given like a S. In one step, you can only insert any character at any index of the string. Return the minimum number of steps to make S palindrome. Okay, so it asks you to get the minimum inserts number of steps, which means like in other words, to insert the minimum number of strings of letters that that makes this string becomes a palindrome. Some examples here. First one, ZZAZZ. It's already a valid palindrome, so then the output is 0. For the second one, MBADM, we need to insert two strings. One for D, the other one is for B here. Okay. Yeah, so on and so forth. Okay. And for single numbers, single letters we consider as a valid palindrome, right? That's a known, right? Okay, so I mean every time when we see a palindrome, it's as if it's like a sign telling you that it's a signal, right? So it's a DP problem. Okay. And so I mean today I'm gonna use two DP solutions, not the top down and bottom or the bottom up. Both of the solutions are all bottom up, but there are like some variations between the thinking process. Okay, so the first one is we just follow the the description. Basically, we're thinking the problem is like every time when we have like a options here, we insert. Okay, so we do an insert. We just use the description from the problem. And you guys might have already know. So for the string here, right? We usually need like I'm sorry. So I'm gonna so the normal definitions for like a string problem, you know, for example, this one. For example, for the palindrome, I and j means the index. Basically, from for the substring, I and j, the minimum, right? The minimum insert, the minimum insert. Okay, so that's the definition of the DP for all the palindrome problem almost. Okay, so since this is the index, right? And let's see, we have, I'm gonna try to, okay, and since we're getting the minimum, right? So we're gonna initialize everything to the maximum, okay? And here, I mean, we can use n plus one or n. I think for this problem, n also works because we're not going back to the minus one. I'll I'll tell you guys. I'll tell you guys why that's the case. Hmm. So to be able to get from I to j, we need to first, when we loop through the I here, we need to loop from the last one to the previous one, so that the j can be on the right side. Right? Otherwise, this thing will become to the j to I. If we loop through I from if we loop I from the smallest to the biggest. Since for me, ij makes more sense. That's why I loop through from the n minus one, and minus one. Basically, I'm looping from n minus one to 0. Okay, and then for the j, right? Then the j is from I to n minus one. Okay, makes sense, right? So, for all the palindrome problem, or even for like a added distance for the string problem, remember this: we always check if the Si is equal to Sj or not. Always have this like conditions here. If else, remember this. Because if I equals to j, it means that we can simply ignore the I and j and only go back to the I plus one and j minus one case, right? Because in this case, if si equals to sj, it means that this these two letters is can be part of the palindrome, right? So we don't have to worry about those two letters anymore, right? Because for the palindrome, like the left side and right side has to be the same. So, but we need a base case. So what's gonna be our base case? Our base case is like all the letters, all the single letter, like is a palindrome, right? And this two is also a palindrome. Okay, so that's our base case. So basically, what I'm doing here, if j minus I is smaller than 2, okay, dp ij equals to what? Equals to the j minus I plus 1. So what I'm doing here is that basically if the I equals to j, okay, if I is the same as j, because as you guys can see, I start from I. So the first one is the j as I equals to j, right? So in that case, it means that single letter here. And another case is the two letters here. So I minus j minus I less than 2 is this case. So for those cases, right, and uh, we need 0. Sorry. Okay. Yeah. Sorry. For that's 0. It means that since we're defining like this is the minimum insert we need to make, we need to do to make this DP, the I and J like a palindrome. But in this case, as long as the length is less than 2 and the SI and SJ are the same, then we don't need to do anything. We simply just assign 0. It means that we don't need to insert any character. Okay. Else what? Else DPI. Else if this like has more values, right? Has more letters. Let's say there's like G, A, B, D, E, and G. So that's the case. This is I, and this is J. So now we can hand over the results to the I plus 1 and J minus 1 because whenever these two are the same, we can simply ignore those two letters and we can just calculate the substrings, which is the I plus 1 and J minus 1. Okay, so that's that. That's the Si equals to Sj case. Now in the else, it means that I and J are not the same. So this is a little bit tricky here. So let's say we have A, B, C, and D. Okay, and this is I, this is J. Okay, so in this case, we have two options to match this either A or B. We can either add A in here. Okay, we can add A here, or we can add D here, right? We have two options. We either add A here to make A and A are valid part of the palindrome, or we can match D. Yeah, basically we either match A or we match D here. But the the tricky part for this problem is that we are actually not actually adding the strings to the we're not we're not actually adding the letters to the string. I think this is some of the thinking obstacles you guys need to really think it through. Let's take a look. Let's say we add a letter here. Let's say we add A here. Okay. And if we add A here, what does it mean? It means that uh, A is here, but J is moving to here. Okay. J moves to here. Okay. And so after moving the J to here, right? Since the A and those A are the same, by using this formula, then we can go back to this Si equals to Sj case here. So in this case, and the I will become minus 1, and the J will be the same J, because here is the J plus 1, right? And then the J, because here it's going to be J plus 1 minus 1, so it will still be the J, but I will be moving towards I minus 1 here. Same thing for if we match D here, right? If we match D here, I mean, this is gone. I will become I minus 1, right? And then by removing this I, D and D here, we have I and, sorry, this is I plus 1, the J minus 1. Okay. Yeah, that's how we simulate the adding process. So when it comes to the coding here, it's pretty straightforward, like ij equals to, since we're getting the minimum, right? We're getting the minimum. Since we're inserting one of the letters, right? And we have to add one here. And after that, it's just like dp I minus 1 j. So this is the case to match j. This is the case. And if we want to match I, it's going to be the dp I j minus 1. Sorry, here I plus 1. Remember this. It's not the I minus 1, because we're moving to the right. Okay. And here we simply return the dp 0 to n minus 1. Okay. I think this should just work. Let's try to run it. Okay. Submit. Yeah, cool. So this one passed, this one, the first if statement is pretty straightforward to understand, right? I think it's the second else here, second part here, which is kind of tricky, because I mean we have to think like as a way, right? Since we're every time when we see like a difference, we try to insert, okay? And when we try to insert, we have two options. We either match I or we match J. So mm, yeah, so basically when we match I here, we insert this one as a J. We insert A here. So now the J will become J plus 1. And then we use this formula to remove both A from to remove A from both sides. And then we have I minus 1. Sorry, we have I plus 1 and J. And same thing for matching the J here. We have dpi J minus 1. At least that's how I interpret this formula. I mean, if you guys have any other better explanations for this like formula, yeah, please do let me know. Leave some comments. I really interested to know that what do you guys think about how to explain this formula here, or state transition function here. Okay, see, so Yeah, that's pretty much it is. Okay, so in the end, we simply return from 0 to n minus 1. That's basically the entire string here. What's the value of this one? Okay. Okay, so that's the first approach, right? I mean, the syncing process a little bit weird, especially for this part. And so the second one is a really, really like a brilliant way of thinking this problem. You know, for adding like letters to a string seems really hard to appreciate, right? For example, especially when we think about these things here, right? But I don't know if you guys have solved a problem. I think number is on number 516. That problem asks you to find, you're given like a string, and it asks you to find the maximum palindrome of a subsequence, a sub maximum sequence palindrome. You guys know the subsequence, right? Subsequence is like yeah, it's the subsequence does not have to be continuous, but it has to keep the original like order. So in this case, we have MBADA, right? So one of the subsequences is M, A, and M. Okay. And for that problem number 516, it asks you you're given like a string. It asks you to find the maximum length of a subsequence that can be it's a valid palindrome. Okay. Yeah. So can you guys think about how can we utilize that solution to solve this problem, right? I think some of you may have already noticed here. So let's say we have this is the maximum subsequence to be a valid palindrome and whose length is 3, right? All we need to do is we just need to use 5 minus 3. That's going to be our answer here. Another example here. Let's see. So the EETCOE, right? So the total length is 8. Okay. So the total length is 8. What's the maximum subsequence that can form a valid palindrome? 3, right? So that's E, E, and E. Okay, that's the maximum subsequence uh, that can be like a valid palindrome, right? This one is 3. So the answer is 8 minus 3 equals to 5, right? So why does this thing work? Why does this solution work? Because, for example, this one, I'm not gonna pick this one as an example. You know, for the subsequence, for those valid subsequence as a palindrome, we can simply ignore those those letters, right? Because those are already a valid palindrome. All we need to care about is the remaining letters, which in this case is B and D. Okay, so to make the remaining letters like to be a uh, valid palindrome, all we need to do is we just need to add the same amount of letters to make those remaining letters to be a valid palindrome, right? Because this is thing we can simply add a B and B and a D and D, right? That's gonna be the valid palindrome. So by utilizing this like the conversion, basically we're converting this problem from an insertion problem to find the maximum subsequence as a palindrome string, which is I think to me is more intuitive to think. So let's try to code that things and same thing, right? I mean, I'm gonna copy these things over, but remember now we're trying to calculate the maximum value, the maximum string, the maximum length of the palindrome. So that's why we need to have like the 0 here. Okay. And still, I think we can do a I minus. I think we can do n here. Hmm. Yeah, sorry. Back here. So I think I told you guys. So I mentioned that we can use n here. The reason being is that we don't have I minus 1 here. Okay, and we're starting from the we're starting from yeah, we're starting from n minus 1 to 0, of course, but you guys can see we have a j minus 1 here, right? But the j minus 1 will not go out of the boundaries because whenever the I and j are the same, we directly uh, set the value here. So there won't be any cases that the j minus 1 will become like minus 1, but it's always safe to keep like a buffer here, but so that's why I'm going to use the same n plus 1 here. So when we have this one, right? So same thing here, right? For I, and the definition actually is the same, the definition of DPI, but instead of getting having the minimum value, the minimum like insertion numbers, now we are in the DPIJ, it it means that for substring I and j, what's the maximum palindrome? Okay, so that's why I'm gonna use the same structure for loop here, and the inner loop is j I to n. Okay, it's actually it's almost identical to the solution here. We still need to check, right? If I is equal to sj. Okay, so same thing here, right? So if j and I is smaller than 2, okay, dpij. So okay, so now we're getting the length, the maximum length of a palindrome. So whenever the j and I, the si and sj are the same, and the j plus j minus 1 is less than 2, it means that for the g and gg, right? That's the two cases we're covering here. So for the g, for a single letter, the length is 1. For the two letter, it's 2. So I'm just combining those two here. Basically, I'm just going to use j minus I plus 1. Okay. Else what? Else dp I and j equals to what? So when there's like a when there is like a two more strings here, let's say A, B, C, D, E, F, A, and this is I, this is J. Similar as this one, but instead we're not doing this, okay? Because we already have A here, right? So A and A means that we already have like at least two strings, two letters that can form like a palindrome, right? So that we have two here as a base case, and for the remaining part, we just hand it over to the subproblem, which is dpi plus j plus 1, j minus 1. Similar as this one, but we're doing like in a reverse order here, since we're getting the maximum value of that. Okay. And okay, so that's that. And how about the else here, right? So for the else, dpi j. Okay. So now when the a and when the I and j are different, okay, so what options do we have, right? We either go when they're different, so which means I and j cannot form a palindrome, so we have to go back basically dp I minus 1, right? We check that. Basically I plus 1. We're moving I on the to the we're moving I to the right side to see, okay, how many what's the maximum palindrome we have from I plus 1 to j. And another thing is we can move the like the j to the left by 1. Okay, right? Yeah, because the current I and j cannot form it, so we have to basically the value must have come from the previous one because from current I and j we cannot add a value on top of it. So we have to go back to the previous one to check. Okay, and yeah, and at the end, the dp0 and 1 here, it stores the maximum palindrome of the entire string. So all we need to do is we just need to do n minus dp0 and to n minus 1. Let's try to run it. It should just work. Submit. Yeah, cool. This one also passed. I mean, as you guys can see, so this thing it's easier, at least for me, it's easier to understand comparing to this insert action here, because here we're not doing any insertion. We're just simply move the cursor to the right or to the left because the current I and j is not a valid. They're not matching, so we cannot use I and j as part of the palindrome. Yeah, I think that's pretty much yeah I want to talk about for this problem. It's a it's a it's an interesting palindrome problem. I mean, either way is fine. You guys can either use the first approach or the second approach. I mean, whichever you guys feel easier to understand. Yeah, but for this one, yeah, like I said, if you guys have a better explanation for this state transition function, do let me know. Leave a comment. I'm really interested in that. Uh, so yeah, I think space and time complexity is pretty straightforward, right? So they're both n squared, right? Because we have a nested for loop here. Uh, cool guys. Thank you so much for watching the video. Stay tuned and see you guys soon. Bye bye.